Let's do this problem right here. The question is asking, let v is equal to 283, find the coordinate vector of v with respect to the ordered basis b, and they have given three vectors right there. So let's see how we can do this. So first of all, what we have to do is we have to arrange this into columns and multiply by a variable. Like for example, this is going to be 1, 1, 2, and we have to multiply by x, y, z, or x1, x2, x3, whatever the alphabet you pick. It doesn't matter. And in this case, I'm choosing the x, y, z. Then plus this is 0, 1, 0, y plus 1, 4, 1, c is equal to the values we given. So it's going to be 283 right here. Then what we have to do is from this one we can form three equations. The first equation is going to be x plus 0y plus 1z is equal to 2. The second equation is going to be x plus y plus 4z is equal to 8. The third equation is going to be 2x plus 0y plus z is equal to 3. Now what I have to do is I have to bring this into matrix form. It's going to be 1 0 1 2 right here, 1 1 4 and 8 right here, and 2 0 1 3 in the other side. Then I had to do to Gauss-Jordan. I had to do the Gauss-Jordan to bring the question they are asking for. When I do the Gauss-Jordan, the value we get in the right side is going to give the final answer. So let's see how we can do this. So first of all, to do the Gauss-Jordan, I have to eliminate all the values above and below the pivot to 0. Make all the value above and below the pivot to equal to 0. In this case, we have 2 right here. To eliminate this one, I can multiply the first equation by -2 and add it to the third equation. So that is going to give me 1 0 1 2 1 1 4 8, and if I multiply the first equation by -2, and this is going to be -2 r1 plus r3, which is going to give me 0 0 in the bottom, and this is going to be 0, and the other one is going to be -2 plus 1 is going to be -1, and we are going to get -2 plus 3 is going to be, wait a minute, so -2 times 2 is going to be -4, -4 plus 3 is going to be -1. Then I continue in the other side. So we have 1 0 1 2, and if you see the third equation, we have -1 in the third column, and the first column we have +1. So we can simply add the third equation with the first one to eliminate the third column in the first row. So let's see what happens if we add it. So this is going to be r3 plus r1. The first one is going to be 1 0, then final one becomes 0 because I'm adding 1 plus -1, so this is going to be 0. Then the last one is going to be 2 plus -1, which is going to become 1. Then we have 1 1 4 in the second row, 8, and third row is in the negative form. I can make it to positive by multiplying it by -1. So I'm multiplying it by -1, and it's going to become 0 0 1. This is going to be 1. Then we have reached the Gauss-Jordan pattern in the top. We have reached the Gauss-Jordan pattern in the bottom, but we have to reach the Gauss-Jordan pattern in the middle. So to reach that one, what I can do is so in this case we have 1 0 1. So 1 0 0 1. So I can eliminate the 4 right here. So to eliminate this one, or I can eliminate the second column by multiplying the first equation by -1, adding it to the second equation. So it's going to become 1 0 0 1, and if I multiply this first equation by -1 and add it to the second equation, this will become 0. Then the second one is going to be 1, and the last one is 4. Then we have 0 0 1. This is going to be 8 1. Then I have to eliminate this 4. To eliminate this 4, I can multiply the third equation by -4 and add it to the second equation. So let's see what happens if I do that. So 1 0 0 1, then I multiply the third equation by -4. So it's going to be -4 r3 plus r2, which is going to give me 0 0 1. This is going to be 0. Then multiply this one by -4 plus 4, 8 is going to be 4. Then at the end we are going to have 0 0 1 1. So let's make sure we get every value right here. So in this case, so here r minus r1 plus r2, minus r1 plus r2, minus 1 plus r2. I didn't do this one, so I made a mistake right here. So this is going to be 7. Therefore this is going to be 7 minus 4. This is going to be 3. So final answer is 1 3 1. So this is my final coordinate. So find the coordinate of vector of v with respect to the ordered basis. So we can say therefore the coordinate vector is vector is 1 3 1. So this is my final answer, and I hope you guys like this video. See you next time.